Bouma sequences of the Permian-Karoo Sea have been long studied by university students from all over. Here we have Dr. Ryan Tucker of Stellenbosch University to introduce to us the Laingsburg Formation in which these sequences are best exposed.
So there are several aspects of this succession that are very interesting, especially kind of environmentally, structurally, and how it develops within the marine setting. But a very simplistic idea is that this is a gravity flow. We're along the continental slope, dipping down into the abyss, and along this slope, we got a lot of unconsolidated sediments. And so at periods, you're going to get slumping. And as they do this, they form a sequence that is repetitive. So many slumps come down, and they're always forming this typical succession. And this is called a Bouma sequence. And what we find is that the highest energies are at the base. They record that initial flow. And then we fine upwards to where it's the ultrafine clays that kind of come out of suspension when the flow actually stops. And we get this energy difference as we go upwards in this succession. Now, classically, a Bouma sequence is subdivided into multiple parts that kind of reflect the energies and the sediment types they're in. So the first one is our A horizon. This is base of flow. So this is, in this flow regime, this is the coarsest material. It falls out of flow immediately. So our sands, our silts, the coarsest material within the succession will always be in this kind of mass-bedded or thick-bedded sandy or silty unit. And then we generally fine upwards to our ultrafine clays. So A horizon, coarsest material, highest energies, initial flow. Now, as we come up, our grain scale decreases, so we can go from a sand to a silt to a clay, but this also represents the weakening or waning of energies within this flow. And so our finer material is starting to fall out, and our laminated structures actually reflect this. So not only our grain scale, but you kind of see these thinly laminated units, and they get finer and finer as we go up. And especially in this section, we record energy dissipating going down that flow, and we get a planar surface due to that nature. But this is much finer than this material, and that records that differential energy. Now, what's also interesting about the Laingsburg is they're stacked. So these are successive flows going down that slope. So our next A horizon is right here. So our sequence boundary, actually this contact is right here. So flow terminated, bit of time, and then our next flow came down.